So the evil twin of the conditional statements and logical expressions is the loop. And again, like I keep saying, any other normal, modern programming language that you have some expression, some experience with will have the same structures, almost the same. There are some exceptions with JavaScript, and we'll see them also when we talk later about arrays. And we'll see them also when we talk about objects. But yeah, because this presentation was supposed to not come directly after the previous one. I'm just stitching them together. So there's a recap to the two JSFiddles and some illustration about the conditional statements in the full meaning of the word. So whenever you have repetitive code, something that has to happen multiple times, your best friend is a loop. And of course, there are many, there is no existence of pretty much any application without loops in it. It can have fixed number of times. It can have an infinite number of times. It can run basically all your operating system and the way that your browser works. It always runs in loops to actually try to catch events. And there's always something that is running and looping. So loops are very basic building blocks to every programming language and every environment and that you might encounter. Yeah, so beware of course, beware of infinite loops because they can be tricky. We'll start with while loops, the easiest ones. So pretty much like the if condition that we saw before, if you change the word if with while, so as long as this condition in the brackets keeps living and keeps evaluating to true, then these statements which are coming in this curly braces block closure will execute. So we'll do them, and then we'll evaluate again and again and again until this condition evaluates to false, and then your loop will stop. Again, not necessary to be true or false, but it needs to evaluate to true or false. For example, strings or positive numbers will evaluate to true, but nulls and empty strings and zeros will be evaluated to false. But that's, again, because JavaScript is special, then you can do that. Actually, also in C++, if you have 0 is actually equivalent to false, and I think it's also equivalent to null. I don't remember that, but I'm sure that 0 and null, 0 and false are equivalent in C++, for example. Yeah, because 0 is also when you say it like 0 could be also a bad word to call someone if he's like bad person or unreliable. And one of the lecturers I used to know used to say, this 0 guy, he's a liar, because he's always getting false things. Okay, so the condition, yeah. To evaluate undefined, we can try. I'm not sure if it will evaluate to false or not, or just throw an error. But interesting question, I'm not sure, so we'll try it in a second. Okay, these two slides are the same, almost. So how the while loop works in terms of flow, we have the condition. First, we evaluate the condition, and if it evaluates to true, then we execute the statements, and then we go back and evaluate it again. And as long as it's true, it will keep looping here and never get out. As soon as the condition evaluates to false, we will bypass the whole block and we'll go down and continue our flow with the program. The while loop is much easier, by the way, to fall into infinite loops, because if you have some condition here that doesn't change, and then you'll keep looping infinitely. So you have to be more careful with while loops. We'll see for loops in a few minutes, and they're less prone maybe to fall into infinity. But since you have a condition here which may or may not be related to the context of your loop, And if it evaluates to true, and if it keeps evaluating to true, you might be trapped in an infinite loop. So this is maybe the easiest and the lightest type of loops, because we just take like a if and we just change the word if with while, and you'll get yourself a loop. But in that case, you have to be careful in what you're doing and not to be falling into infinite loops here. So here's an example. We have a counter variable that starts, we are initiating it to 0, initializing it, and then we are checking a condition. If the counter is smaller than 10, then we are executing this, we're writing to the console, and the second statement is incrementing the counter. So first it will be 0, then it will be 1, then it will execute again, it will be 2 and 3 and 4, 5. When we reach the number 10, actually, we'll already skip the loop because number 10 is not smaller than 10. So we're counting from 0 to 9, which means 10 iterations. But computer guys like to be smartass, so it has to be from 0 to 9 instead of 1 to 10. And this would be the output. We have the browser console, and we'll see number, column, and counter, and every time incremented. Once we reach the number 10, we actually don't execute it anymore, and we go on with our lives. Another example, reading a string, parsing it as an integer number. Then we have two more variables here, number and sum. The number is actually our loop counter, so we are running the number n number of times. Okay, so we have, let's say, 5 in the input. We read it 5. That means we'll run this loop between 1 to 5 because every time we increment the number, and we also increment the sum with the number that we currently have, and also the result. So. Yeah, not extremely intuitive, but an example nevertheless. Checking if a number is prime number or not. We're doing this here by how we're doing this by dividing the number with all the numbers that are actually from 2 to this number itself. So what we have here is a more complex condition. As you can see, we have one part which says that we found that the number is not prime. That means that it has a divider, which is between 2 and this number. So we're running through all the numbers until we reach the current number, and we try to divide and see if one of them actually divides with no remainder. That means that the number is not a prime number. And then we are setting this condition to false. So next time we get to the iteration, even though our counter didn't finish counting, we'll still get out because the first condition here will evaluate to false. So maybe not the best method to check for prime numbers, but actually, there are not so many methods to check for prime numbers. But that's one way to just check through all the numbers until you reach your number and see which one of them, if there is any of them that actually divides with no remainder. So prime here will be true or false. And once we're done with the loop, we'll print out the result, whether we found that it's true or it's false. Okay, a demo. This, by the way, this guy is more about recursions more than loops. But he's a cool guy. So we are running now here a while loop of random numbers. So we have the number variable that gets some random number here. And as long as the number is not dividable by 10, we keep executing the loop until we find such a number. And then this will break, and we will exit the while, and we'll print the word found in this. Yeah, question? I think the random number doesn't give a whole number. It gives a floating point. So we are, it's not necessarily going to be divisible by 10. Okay. And here we have the prime number checker, which is what we saw in the slide. We have another operation here. So actually, this code will get executed as soon as the page gets loaded. And this one will be executed on click. I hope the text reads correctly. Check prime. So we have a text box. And to check the prime number, we again read the number from the text box. We have a divider starting with 2. The max divider is the square root of the current number, because otherwise it means it could be divided. And we have the loop running from the divider from 2 till the square root of our number, and we're checking if it's prime. That means that we find a divider here, and we set the prime to be false. That means that we found the divider for the number. And if we haven't found any, we just increment the divider to the next one. In the end, we just write to the console that we found if it's prime or not prime. Again, it's a little bit clumsy, but why the hell not? Okay, so we found here the number. Actually, let me see again. Yeah, we run through the numbers, and every time we run through the loop, we put them into the console. So here we just ran 2 iterations. On the first one, we got this number, and on the second one, we found the divided by 10. Let's try this again. Okay, so this time we got a few more. And to check prime, we'll run the other loop. So, for example, okay, so it ran through all the numbers until a number which is equivalent to square root of 73, trying to divide, and something like 40. Is this clear, this demo, this example? Okay, break. We've seen break operator before in the switch case. Break basically breaks you out of the current curly braces scope that you're running in. In the context of your loop, it's most useful. Again, I don't think it's the most elegant way, but sometimes you need to use it. So breaking out anytime you need will be, for example, we have an infinite loop here. While true is totally okay to be written in JavaScript. You can write a loop like this. It will be an infinite loop because this will never, ever, ever evaluate to something which is not true. And this will just keep iterating. So in that case, if you're stuck in such an endless loop, what you need is to break out of it artificially. And what we're doing here, if the number n is equal to 1, we're breaking out, regardless of the fact that we're infinitely looping here. Okay, so this is this function will calculate factorials, you know, the one with the exclamation point. So it will run through a number, let's say any integer number that you got, and it will decrement it on every loop iteration and try to multiply it with itself. It will have the factorial string, so it will concatenate strings, this times that, and every time we iterate, we decrement our number, which is n, and also calculate it into the other variable called fact. Once the n gets decremented to number 1, then we cannot go further. Otherwise, we'll go to 0 or to negative numbers, and if we go to 0, we'll just put everything the result to 0, and otherwise we'll start getting wrong answers. So once we get to 1, we break out of the loop. But since we don't know in advance how many iterations we're going to have, actually we do know because we have the number, right? We could have done it more elegant than this, but this is just to give the idea of what break can do. So it's not well written, but I mean, you could use this condition here instead of writing true here. So basically, if the number is equal to 1, we are breaking out. So we could say that if the number is not equal, as long as the number is not equal to 1, we'll keep looping here. And that would be a more elegant way to write this loop. Otherwise, we're using this number also for calculation and for checking, and if we reach 1, we break out. So let's take a small number like 5, and clicking will get into our breakpoint, which is in the function. So first thing we do is read the number, which is now containing our number 5. The fact will be, the factorial calculation will be 1, because this is our number that we're going to multiply every time with a smaller and smaller number. And the string, which will concatenate n factorial equals to something. And then we get into the loop, and while true will always be true, but our number is bigger than 1, so we'll continue with the next iteration. First, we build a factorial string that now looks like this, and then multiply by the number, which is now contains the number 5. And once we run this, we decrement it to 4, and we are now back in the beginning of the loop again to loop back. So we're checking again our condition. It's still 4, so it's not 1. Adding to the string, adding to the number. This now looks like this, and this now looks like this. And decrementing, and now we're at 3, and going back to the beginning. So we are looping again and again. The number now is 2. So our string now looks like this, and our number factorial looks like this, and our number now is 1. So except the fact that the string here is pretty ugly because it ends with asterisk. Sorry, if you're epileptic, please leave the room. Okay, so we have, again, we're going into the loop because nothing will ever stop us except this if statement that checks if the number is equal to 1. That means there's no more to calculate. So we're going to the break statement, and we've broken out of this. Now we're getting the string and adding to it the result and writing to the console. Okay, that's how they broke it. So they added, since we had the last asterisk, it added 1 in the end, so it will be nicely formed. And then we're writing the string to the console. So back to the real world. Once we execute this, we get this into our console. We can remove this. And that's the result. Okay with this? Second type of loops, do while. Almost the same as while. The difference here is how it executes and the order of execution. Because with while, you first check what's your condition. And then if it's evaluating to true, you start executing. With do while, you're just running ahead and doing something, and then you're checking if you made a terrible mistake or not. So do while will first execute and then check the condition. Other than that they are reversed in their operation. They are similar in their logic. So do while gets everything in reverse. We don't even get to the condition. First, you do what I tell you, and then check what I also tell you. In any case, I tell you. Okay, so here's another example of calculating the factorial number, almost similar to the previous one. Again, we have a number, and again, we are decrementing it every time. But since before we needed to first check if we reach now 1 or not, and then break out of it, we could now do first calculate the number that we have at hand, and then decrement it, and while n. Now, again, this is not pretty because this is not using true, false, and this is not using actually a Boolean expression. What we're evaluating here is the number n. And as long as the number n is not 0, it will evaluate a true. So if we have a positive integer here, it will run and execute it, and every time it will decrement. It looks a little bit more compact because we don't need all the other stuff. And once we reach the number 0, we'll skip this loop and continue with our lives. Here we are calculating the product of all the numbers in an interval between two numbers. Again, these examples are a bit arithmetic and they're a bit tedious, but I think they're good examples to talk about looping in any case. So we can dive into what it tries to do. We have a product and we have a number between, we have some number n and we have another number m. And between these two numbers, as long as our number counter is bigger than n, but still not equal to m, we are just multiplying here and building a string of whatever this function is called in math. But again, the logic of and the flow of this program is pretty easy, I think, and clear. Pretty much what we've seen, the same structures, the same functions, just that we're doing them with do while, except with while do something. So this is our demo running the two functions. And this is really interesting, 5 in the power of 3. So it's not a range, but actually repeating the loop as the number of times that we need to multiply our number. More common structures for loops. They are a little more complex than the while loops. But again, I'll say it again, if you've used any normal language in the past couple of years, this will be, including C and C++, this will be familiar to you. So we have here 3 parts. Just like everything else in life, we have initialization, test, and update. So the first part, we have the word for, and in brackets, we put 3 things. First, we put some kind of initialization. Again, by the way, none of these things are mandatory. You can leave them blank. It will still be OK. They can be empty statements. There can be multiple statements, and they can be complex conditions and checks, or completely empty. I recommend to keep it as simple as possible when you're doing something like a for loop, because it can get nasty to follow up and understand. Usually what you would do, and if you don't want to use other types of loops, is you'll initialize some kind of counter. In this case, we have the number from 0. Then the second part coming after the semicolon is a check. So this is our condition for the loop. And the third part, which comes after the condition, is what to do every time we iterate. So we got everything in one. We'll have our loop counter, we have our check, and we have what to do next. So everything is enclosed here in the definition of our loop. By the way, again, it doesn't mean that this has to, that the first one has to connect to the second one or to the third one. You can check something completely different in this for loop, and you can do something completely different and increment your counter if you really want. But usually, they are tied together because that's the recommended way of using this structure. But I've seen it used not specifically like this. So here's a simple example of, again, running through numbers. That's the basic idea of using for. We have the number from 0, and as long as the number is smaller than 10, meaning that if we reach 10, we already break out of the loop. And every time we iterate, we increment the number. So we don't need any more code inside our loop. We already have it defined on how many times it's going to run and what it's going to do every time. And we can log the numbers one by one into the console. Again, the factorial, much, much smaller and more concise. So we have a number n, and we have the loop counter I, and every time we increment it, and we just take the factorial, which is the number which is getting them calculated every time, and just do the calculation in the loop. And this assignment, I think we've seen it in the previous time. This just means multiply and put the result into this variable. Okay, like I said, it can get pretty nasty and complex. So here, for example, we have 2 different variables in the initialization. And we have a condition here, then as long as I is smaller or equal to 128. And what we're doing is actually we're executing 2 statements every time on every loop iteration. So this can be quite complex. And once you see something like this, it's already less readable and less understandable and much more less eye-pleasing. So I suggest to keep things simple, concise, and make sure that your loops and every part of your code is readable and well written. I don't like this. But it's in my presentation. But I don't like it. Doesn't mean I have to like it. I don't like it. Okay, calculating the power. Again, everything is in one place. You have the I, which is the loop counter, going from 0 to m minus 1, actually. And every time we're iterating, we're incrementing the loop counter. And the result starting from 1, so that we can multiply it every time. This one I like. Let's see, I don't know why there's a graph here. It doesn't mean anything. It doesn't mean anything, this graph. It's just a graph. Yes, it shouldn't be here. Okay, the power. I got the power. So, again, for loop, we have power, which is actually a variable. Notice that this variable lives in the closure of this loop. This means that between this and that curly braces, this variable exists and defined. Yeah, this is the scope. The scope of this variable is just the loop. So we have it counting from 0 to m minus 1. And every time we iterate, we increment it by 1. Then we take our product, which starts with 1, and every time gets multiplied. And we have also a string, so every time we append to the string. Since this one, notice that this starts as an integer, okay? And this starts as a string. And that's why these functions of multiplying or appending have different meanings. This means that this number n will get multiplied as a number, and this number n here will get casted as a string and appended to the string. And every time we iterate, we're checking if we have reached the end of the loop, and if we haven't reached, if we have one more iteration, it means we're not yet in m minus 1, then we append this to the string as well. A little bit clumsy, but it's also okay to do it like that. So we'll run it from 0 to m minus 1, append the numbers, calculate, and then build our string, and then put it all to the screen, and everybody is happy. And the effect is pretty similar to what we've seen so far. Let's do 6. I don't know if it's going to be too big. Not too big. 6666, the new number of the beast. Yeah, nested loops. Just like with ifs and just like with any other fragment of code, can become spaghetti and can become not readable and can become multiple nested, and also take into account the effect on performance, and it's very easy to write a few loops, one in each other, and running them and getting a huge piece of code that will take a lot of time to run and will be complex and heavy. So take this into account. But sometimes, for example, if you have a matrix that you want to scan, you can scan rows and columns. And the easy way to do this is with two nested loops, one to go in columns and one to go in rows. And that's how you get to scan all of them. So it's also common practice, but be careful with nested code. Don't over-nest your code. So here's an example of a nested loop. Printing a triangle that actually prints numbers from 1 till n. So we have a row and a column counter, and we are just building strings. So actually what we're doing is appending strings every time. We're building bigger and bigger lines. The inner string will actually build your row and append numbers. Once this loop is finished, we'll have a line break, and we'll go into the next, and then actually we'll get to the next row. Yeah, I think we'll see it on the live. Again, print all the prime numbers between in a specific interval. So we've seen a way to catch the prime number by trying to divide and see if there's any number between 2 and a max divider which goes when it leaves no remainder. So this is what's happening in the inner loop here. But there's also the outer loop that will check all the numbers between n and m, and on those it will run this loop. So all these variables that live inside the scope and the closure of this bigger loop will get re-evaluated every time. They'll get started again, they'll get initialized again, and then we'll start this. The only thing that changes is this number here that gets every time incremented here. But apart from that, there's a nested while inside our for loop that does this check for each of the number between n and m. 1, 2, 3, 4 nested loops. So print all the digit numbers in format ABCD, such as A plus B equals C plus D. So we'll have to run through all the numbers, all the combinations between 1 and 9. And here between, so it will be a two-digit number. And then between 0 and 9 is the second digit, and 0 and 9 the third digit, and 0 and 9 the fourth digit. And every time we just check. So this is basically what we're trying to do. Just check this condition, and if it is, we'll print them out and print which numbers are those. Apart from that, it will just go through all these numbers and every time increment another one, and then start the outer loop again and go through it, and then the inner loop will go again. And then when we're finished with this, it will go the outer loop again, and these will start running again. And then the outer loop will increment once more, and the whole cycle will start again. So that's going to be quite big. 1, 2, 3, 4, 5, 6. Okay, again, going through combinations of 6 numbers and running from 1 to 44. So trying to find all the combinations of all the numbers between the first 1 to 44, then I2, starting. Okay, so we are narrowing it down every time, starting from 1, and then the other one will start from 2 and from 3. We'll just put all the combinations of 6 numbers to 49. Yeah, it's smart because it's incrementing the other and actually shifting the whole range as it goes in, but that's a lot of loops. Yeah, infinite loops, like I mentioned, and like I said, in for loops, there is no obligation to put anything. So this is also valid code. No jokes on my name. Okay, so we've seen this one, taking a number here and going from 1 to the number of rows that we want to go. And on each row, we're just going to print. We have the number of columns that we want to go. So our columns will get longer and longer because we're starting from row 1, and then we'll count from 1 to 1, and then we'll go to the row 2, and we'll count from row 1 to 2, and then to 3, and then to 4, and then to the number that. So every time we increment, and every time we finish, every time we run here, we put the current column, which starts from 1 every time, and then 1, 2, and then 1, 2, 3, and then 1, 2, 3, 4, put a space, and print it out, and then put an empty line break and go on to the next iteration. So we have 2 iterations, one to increment the lines every time and print all the columns, which grows because the outer counter grows, and one to print each row separately. And that's the result. So the nested loops of prime numbers, again, so we've seen this while loop that checks all the numbers until the max divider, which is a square root, and every time we start this, so this is basically the same function that we've seen before, except that it will check for all the numbers in the range from start to end, and these are the 2 numbers that we are reading here from these text fields. So between 2 and 19, it will just go through each of those numbers and try to find which of those is prime. So this is our printed result. Yeah, looks okay to me. The last type of loops, the for in loops, that actually now are also, let's say, standard in other languages too, but it wasn't always the case. Once we have in JavaScript objects, or what we call associative arrays, we have properties that we can iterate through without a counter, and what JavaScript will give us is an iterator that will go through the properties of the object or the properties of the array. So, for example, here we're going to talk after some minutes of break, we're going to talk about arrays. So here we're instantiating an array and initializing it with numbers. And instead of actually running with an array and a loop counter and an iterator of going each one of the objects here, we can do a for, and we get an index which is actually not a counter, but once we do for in an object, an array in JavaScript is basically of type object, where the elements of the array are actually properties. We get iterating through those properties, and we can print them out. So I think we could also do this with a dot notation. I can check it. And here we have an object document, which is the document object which the browser gives us access to when we want to manipulate document elements in our HTML document. And we can run through the properties, all the properties that are available to us, doing a for in loop. And again, we can print out the property. And again, I think here we can use notation of document dot property. But actually, I'm not 100% sure, but I want to check this. So here we have, all the object properties, and we have an array, and print all. Okay, so we have the function print all that goes through and does a var property in the object, which is given here as an argument, and we're running through all those properties and printing them out one by one. I have to check if this will work also with a dot notation. So here we are feeding it with the array, and here we're feeding it with the document. And here we have some object, but I don't want to really go through objects because we'll talk about objects next time. Let's just see the results here. Okay. Okay, so here's the first time this function runs. It's at least giving us the option to see when it starts and when it ends, because it logs these dotted lines every time. So first time we're running through the array, so we're actually iterating through the properties and seeing what they are. And then we get the document, and each of those are properties of the document, and we can see them printed out. So we're iterating through all the properties of the document object until here. And here we're running through the properties of this object that was defined here. One thing I want to check if I'm right, but actually no, this will not work, because it will work only if there's a property named property. Yeah, so this will probably not work. Yeah, okay. Okay, it's clear, right? I hope.